Hi, this is Vivian Arana, founder and instructor at School of AI. If you've been hearing about quantum computing but aren't sure where to start or how to go from theory to real world systems, this program is designed for you. Over the next 52 weeks, you'll move from core foundations all the way to building and understanding production level quantum and post quantum systems. This isn't just about concepts, it's about learning how to think, design, and build in the next era of computing. Let's walk through what's covered. In the first phase, the focus is on building a strong foundation in quantum computing. You'll start by understanding the core principles, things like qubits, superposition, and entanglement, and how they differ fundamentally from classical computing. Alongside that, you'll build the mathematical intuition needed, especially around linear algebra, complex vectors, and Dirac notation. From there, you'll move into quantum circuits and gate based computing, learning how quantum information is actually processed. The goal here is not just to understand the theory, but to be able to visualize and reason about quantum states and transformations. By the end of this phase, you'll have a solid mental model of how quantum systems work at a foundational level. Once the foundations are in place, the next step is applying that knowledge to real systems. You'll explore some of the most important quantum algorithms, including Grover's algorithm, Shor's algorithm, and the quantum Fourier transform, understanding not just how they work, but where they create real advantages. From there, the focus shifts to building. You'll work with hybrid quantum classical architectures, write programs using Qiskit, and simulate quantum circuits before running them on actual quantum hardware. This is where things become practical. You'll see how quantum computing is applied to areas like optimization, artificial intelligence, and chemistry, bridging the gap between theory and real world impact. In the final phase, the focus expands beyond systems into security, scale, and the future of computing. You'll dive into post quantum cryptography, understanding how quantum computing impacts today's security systems and what new approaches like lattice based cryptography are emerging to address these challenges. You'll also explore quantum error correction and fault tolerance, which are critical for making quantum systems reliable at scale. Alongside that, you'll look at quantum cloud platforms, networking, and the infrastructure needed to support real world deployment. Finally, you'll step into the bigger picture, enterprise strategy, identifying high value use cases, and understanding where quantum fits alongside emerging paradigms like neuromorphic and hybrid computing. This is about preparing not just for today, but for what's coming next.